Hello world, today we are going to implement queue data structure, which is very important to understand how does a sequential execution can happen in the data structure. So it will help us to build a sequential thing like doing data analytics and mining of the data mining and AI, machine learning. Everywhere these concepts are going to be implement. It's a very initial at the time right now, and future is going to be very massive, right? So NQ is a process where you are going to be adding the data according to the queue, and DQ is an operation you are executing or removing the data according to the queue. So just take an example of you're taking a ticket in your cinema, for your cinema, and the same implementations, who would be the first person, he will get a ticket and he will actually leave the queue. So let's implement it, which is very important. Let's start. Okay, so now what we are gonna do, we are just gonna implement our queue operation in the Java. So let's start and select the Java. Okay. So have to search in the compiler Java file. So let's start. So it is the main function. We are just removing this and we are renaming the name of this file, that is, I'm calling it queue. Okay, so we are actually implementing a queue operation. So to start it, I'm assuming you have an idea about Java language, and so public class queue is the name of it, and public static void main string args. Okay, so system dot hello world. So let's make queue. Yeah, I'm tapping here. Let's make queue. Okay, so let us check whether everything is proper or not. Yeah, let me execute the program. It is taking too much time. Yeah, it has been done. So what we are going to do, we are going to be actually define our data elements or parameters. So I'm setting a private int. First of we will see the max size, and where will be the an elemental index value which defines where is the max index, what is the last element of the queue, right? So okay, front, and we are just writing here current size. Okay, current size, fine. Okay. So now what we have to do, and we require one more thing, that is called array, int array. So queue is QueueArray. I'm calling it QueueArray. Okay. So let us make one constructor which defines the queue, right? Queue is here. We are passing the size of the array as an input parameter here, and we are just max size would be always v, whatever the value you are going to be passed here, and this QueueArray will be the size of the max size. Okay, and then what we have to do here, another thing, we will make front at a 0th position, and rear at -1 position, and current size would be always also into the 0th position. Okay, now let us say system dot out dot println which queue constructor. Okay, simple. So it has been done, and we are just initializing it queue. Let us make it QX equals to new queue. That is 3 is the max value. We are going to just, once I initialize it, automatically I don't have to call this function. Once the program executes, it will automatically call. So let's do this. Okay, queue constructor built. Okay, so to implement these whole things, what we have to do, NQ and DQ operation. But I want to, as we did in the stack, you can check out that video over there, and we are just building here Boolean function which give a proper information whether this queue is full or not. Okay, so I'm just calling it full and returning the value. If current size equals to max size, then it is going to be full. And another thing we are going to do the Boolean operation, which is we are going to check empty. We are writing here function empty. So let us check return the value just current size when current size equals to 0. Okay, so let us perform NQ operation. We are going to insert the information into an array. Okay, let void q is here. We are going to take again value as a v. Okay, so if not full, then only we have to perform the NQ operation. So rare equals to rare plus 1 percentile, because the integer value cannot be decimal, so that's why we are doing it. Okay, so this rare value, and we are just adding the QueueArray of the rare size equals to the value whatever you are gonna send from your function. Okay, from your main function. Okay, so system dot out dot println, here the value has been added. Okay, this has been added here, plus q function and passing this rare value. Okay, and the current size will be actually increase plus plus. So let's execute this, and we have already did it, and just call it, instead of q we have to call it nq. Okay, nq function, and I'm passing this. Let us execute whether this system work properly or not. Okay, we got it. So it has been added. So it is the time to perform DQ operation as well. But what is the size of the queue? I'm going to implement the same thing here. It's like x dot nq one more. If these things happen, if array size is full, then we just have to add this else, and system dot out println, which is going to be we have to sorry q is full. Cool. So now let us nq. Okay, and x dot nq. Just adding this 3 elements on this passing. If you add it, you will get a message from here. These all things have been added. So the q, the max value is 3. Whenever I'm adding another element, so what should I have to do? It crosses the max value, so it should have to be give. Sorry, I cannot add any number. We have to, sorry, q is full. This message you will get, and I'm just saying 909098 or something 9800. So just have a look here. It's taking too much time. Q is full. Once it crosses the max value, here 3 is the max value, here 3 is the max value. I will give this code into the description, you can easily find over there, no issue. So let us make, if Q got full, we just have to perform DQ operation, right? So just public end DQ, it is here, and we are just if Q is not empty, then only we have to perform this, right? So front equals to front plus 1 percentile max value. Okay, front plus 1 max value, and then we just have to say here what is the before that we have to hold that value. So to hold that, what is the current value, int rv is a removing value, and that is called QArray as the size of the front, right? So plus 1 percentile max value, and current should have to be front plus plus. You just have to say the return the rv. Okay, so that's how things are going to be in such a way. Clear? So if else, suppose Q is empty, we have to say directly, sorry, Q is empty, you cannot perform system.out. Okay, so this is very important. Let's run here. So I'm getting error. I have to add this semicolon. So 37, line number 37, we are getting error. System.out.println, the Q is not empty. The system line number 37. Then issue the bracket. Everything is perfect. Yeah. Q1. Okay. What is the issue? Missing return statement. So we will return this as well, -1. So let's do this. So to understand what is the actual front value, and we will perform DQ, and we will know what is the next front value. To know that, we just have to say let int p. Okay, so this is the function which gives us a return as if is not empty, is not empty, then we have to perform this. Okay, return the value which is in the front, right? QArray into the front. Okay, else the same. Sorry, system.out.println. Sorry, Q is empty. Okay, so these things will be there, and let us perform another thing, just DQ operation. DQ, I'm just calling this, and I'm checking after this out.println next Q element is plus dot two. So x.pick system.symbol is not fine, so I think I let it stay. Everything is fine. X.pick is also a function. Okay, variable system.out spelling issue. Okay, just have a look here. Now, statement, the missing statements at the line number 48. Just have a look here. Okay, return we have to pass -1. Yeah. So what is just happening? Okay, the element which is available in the last read, we are getting it right. So what do you have to do here? Once we do this, we just have to say minus minus. Let's have a look. Yeah. So one second. It should have to be plus plus. Current value should have to be also plus plus. Current value should have to be plus. Okay. That's done. Here. Okay. So what would be the current size? Current size is that's right. Everything is perfect now, and let's complete it.